Hello and welcome to Module 4 in Big Data. Jumping straight in, we'll go over what we talk about in this is about solving basic data manipulation problems with Apache Spark. Scala is a language that Spark was written in. I should really fix the slide, but I took it from the course room, so I'm trying to be consistent. Apache Scala I don't think is a thing. Scala is a programming language based loosely off of Java. I think of it as pretty Java, easier to write Java. So anyway, I digress. The basic idea here is that you should be able to appraise the concepts of functional programming within the context of Apache Spark, utilizing Scala. Critique the operation of resilient data types in the context of Apache Spark, and apply the concept of filtering. So what is it? What is Spark? And basically, the short answer is, and a bit of a marketing-esque answer as well, it is a big data unified platform that is optimized for processing. It's not a storage platform like, say, Hadoop. It is focused pretty much exclusively on processing. And that's one of the key distinctions between it is that, and something like MapReduce and Hadoop, is that storage is assumed to be done outside of Spark itself. Spark can work on lots of different other platforms, including Hadoop, but it also can work against things like S3 buckets and blob storage inside of Azure and Azure Data Lake stores and so on. So the storage is independent, and it's highly optimized to be able to do that. The common uses is around analytics, data wrangling, and processing and stream processing. And so why does everybody like Spark? Well, that 100 times faster than Hadoop's MapReduce. And that depends on the situation. That 100 times is typically if you're doing things in memory. It's still significantly, I think, 10 to 50 times faster if you do them where it's touching a disk. That's not to say that Spark requires everything to be in memory. It does have the ability to spill to disk, but if it's all in memory, then it is significantly faster, 100 times, like 2 orders of magnitude. So some key concepts and key words to understand. These are kind of foundational elements you kind of really need to get. Resilient distributed data sets, RDDs. It is basically the foundation of what Spark is. The idea is that you have a data set that enables you to do recovery by tracking what's being done to it so that you can redo it if something were to happen to the intermediate result. There's essentially kind of 2 different big buckets of things. There are transformations where you take a data set from one RDD and you produce another RDD. And the other is an action where you're actually applying something and making something happen. And it is key to understand that Spark does utilize lazy evaluation. Whenever you're issuing a bunch of commands, it may be like, man, this thing's really fast, right? But you haven't actually done anything yet. You've told it what you would like to do. Spark then figures out how to do whatever it is it needs to do. It is, as I mentioned, RDD can be in memory, and if it is really, really fast. If it's not in memory and it spills to disk because it's too big, then it's still fast, but not as fast as it is if it's in memory. There is this concept of partitioning RDDs across different locations with the data, and that's kind of a fundamental construct of RDDs. You don't actually typically use RDD directly. There's layers of the APIs. You generally are dealing with a higher level API, but it's the underpinning, it's the foundation on which all of the other stuff kind of works. Another key kind of concept is Spark SQL, and basically what that is something very similar to Hive in the sense that you write SQL statements and it figures out what to do, and it essentially converts them into Spark jobs underneath the covers, right? And it's very similar to what you would see otherwise. And the basic idea, there's several ways you can do it. One way you can do it is execute it as it is on the screen there, where you're running a select statement essentially inside of a spark.sql statement, and that's producing a data frame. That's one approach. There are lots of different other ones, but that is one very simple way of doing it. And the basic idea there is you have a data frame that you created up above where you give it a name as a table, essentially, And then you can access that table using a select. So up here we're saying take this data frame and create or replace a temporary view, calling it people. And down here we're saying select star from people. Right. So it's similar sort of concept, and you wouldn't do anything like this, because why not work directly with the data frame unless you don't know Scala and you want to write SQL. So that's one approach. The basic idea of the programming model is that it does utilize the concept of both a unified platform. That was one of the words I used early on. And what does that mean? And what it means is that it does both streaming and batch processing in the same sort of environment. That was kind of unheard of whenever it first kind of came along, but it is pretty compelling. What that means is you only need one place to do your work, and it also is pretty relevant when you talk about something like a Lambda architecture, where you potentially are doing near real-time processing in streaming mode, and then later on you want to come back and do a more refined processing in batch mode. The basic idea is that we do the streaming by doing something called a micro batch, and it, as the name kind of implies, it's a little batch, but you don't exactly terminate. You start, you do some processing, and then you start again in a little bit. So it's not in the sense of a true stream processing system where it's continually running, listening on something, a queue or a port or whatever, for something to arrive that then causes the actions to occur. That's a true streaming system where the arrival of something is what triggers the processing. Rather, what causes the processing to occur is every so often it checks for something to do. So it's a subtlety difference, but that's one of the things. Another sort of concept around, and this isn't unusual necessarily in stream processing, is to view that what you're processing on is essentially an unbounded table on which you apply some sort of temporal construct, a window of some form, to control what it is you're going to process. So the basic idea is you get some data coming in, and you pick up X amount of it based upon time. Maybe it's since the last time you ran, and you produce some output. And that's essentially what the second slide here is showing, is that maybe we trigger every second. And this is showing the timeline of data up to T to 1 and data up to T to 2 and so on. There are various choices on how this is done. This is showing that basically every time it's running, it's getting the same data it's done more than once, and it's reprocessing essentially. Your other alternative is going to be to not do that and instead use a windowed approach to not reconsider those things you previously considered, although there are ways you can do that in a fairly efficient way. Another sort of concept that is mentioned in this module is MLlib, and that's a machine learning library intended for Spark. And the idea is to be able to do algorithms in a distributed fashion that utilize machine learning concepts and machine learning pipelines to do essentially workflows and so on. You can do things like cross-validator to tune the parameters, and also the model persistence, essentially saving and loading the models. So the equivalent of pickling them or whatever technology you might be using. So an example on the screen of creating some data, and we're creating something with some features and some labels, doing some setting the number of iterations, then telling to call fit, sound familiar, and then potentially getting back the weights and then taking a look at what it looks like if you use the weights to do prediction. So pretty similar. The reason that you would care is there are times that you move, when you're doing machine learning in general, that you move into that realm of big data and machine learning. And in that situation, MLlib is one of the options you might consider. So doing machine learning at scale across a cluster of a Spark cluster is quite compelling. Another thing that comes up is the concept of GraphX, which is a graph processing library. This is a mathematical graph concept made up of nodes and edges, and associated with nodes and edges are essentially properties or attributes that are tied to them. That's one of the key things with a graph database, or graph in general, mathematical graph, is that the edges are as important as the nodes, and maybe even more so, and annotating them or or tagging them with attributes is as important as well. And graph processing is something that's been around for quite a while. Things like the PageRank algorithm inside of Google for figuring out a good way to prioritize search results is a perfect example. And being able to do it again at scale is a significant issue, because these sometimes are both iterative in nature and also pretty big. So something to be aware of as a way of doing essentially graph processing on top of data. This is kind of a counterexample, not necessarily a great thing, because you can see here it's actually using an RDD directly. Generally speaking, the current guidance is to move away from RDDs and to do data frames instead for performance reasons, if nothing else. Moving on to deliverable 4, because no conversation would be complete without talking about what you need to do. So your competency is to solve basic data manipulation problems using Apache, Scala, Spark. And you can take a look at the rubric to determine how you're going to be graded. I strongly recommend you do so, because I will grade to the rubric. You're basically a international data clearinghouse that provides data services to thousands of customers. Some of the customers have a lot of data, and MapReduce is being utilized. So you're going to basically show in a paper, a white paper, the advantages that Apache Spark has over MapReduce. In addition, you will need to demonstrate how easy it is to solve problems using Scala, and you might even want to go crazy and throw in a couple other languages too. That's a key thing to understand with Spark in general. Is yes, Scala is kind of the native language. It's what it was written in, and there is some things that can only be done in Scala, but it's a very, very select set of things. Part of what makes Spark really compelling is something like Python, and using PySpark as the language, or SQL as the language, or even R as the language you're using to interact with Spark. So that means that if somebody comes to the table knowing Python but not knowing Scala, they can still use Spark if they master the concepts and the constructs that are used inside of Spark. So you feel free to mention that, but I will, as I mentioned, be grading to the rubric, so make sure you follow what it says rather than my ramblings here. Write a simple script using Spark Scala to list the top 20 companies and their locations contained in a Fortune 500 data set. You need to basically report your findings in the white paper. So you do need to load a data frame into Spark and then do essentially get the top 20. There's several ways you could do that. You could do it in Python, you could do it in Scala, or you could do it in SQL. And so probably for this assignment, good idea to do it in Scala since it's calling it out. But for your personal knowledge, understand that you do have some choices in languages here. And then write a convincing white paper that promotes your capabilities to provide clients with the best data services possible. To do that, you need to explain how Spark relies on RDDs and how that what's the approach and philosophy of that. Talk a bit about the direct acyclic graphs, so the DAGs that are used to monitor RDD calculations and also potentially reconstruct them if something bad happens, like a node dies. Explain the advantages of Spark's in-memory processing capability over MapReduce. 2 or 3 things that pop to mind. 1, in-memory. 2, iteration, because MapReduce is not really something that naturally does iteration very well, whereas Spark is great at iteration, hence MLlib. Moving on to the next item, provide a look at the underlying technology that provides Spark with these important capabilities. So what makes it all work? And then using the script instructions in step 1, explain how easy it is to solve a problem using Scala. Include the screenshots of your script and the result, and a detailed explanation of your work. Some resources and references that are pretty good. The Towards Data Science is a pretty good set of blogs. They are blogs. They're not scholarly. Don't mistake them as something that should be really cited per se, but they are useful in learning. 21 Steps Getting Started with Apache Spark, also good. There are several kind of seminal or key books that you would want to consider. And fortunately, they're in the O'Reilly database, which we have access to. So if you go into, and it's always great when I go off script, right? But if I open up a window that doesn't have any kind of PII information, and we go into the O'Reilly home, which if you aren't familiar, this is a great resource that is provided to you as a student. So definitely worth taking a look at. And if you type for, probably go ahead and say Apache Spark, right? So we don't get some other kind of Spark. And take a look. There's quite a few books. I'm looking for a particular one, and it's probably a little further back because it is a little older. I don't think it was that. Bear with me. Yeah, Spark the Definitive Guide. This is pretty much the Spark book, and the reason being, these are kind of the guys that made it, right, or a large portion of it. So do take a look at that, and if you're wanting to truly learn much about Spark, it's a great resource. It is definitely a Spark resource, so something to take a look at and consider. Not necessarily a Databricks resource, which we'll talk about Databricks going forward, but definitely it is the Spark book. So take a look at that. The rubric, criterion 1, a thorough appraisal of the functional programming concepts within the context of Apache, Scala, Spark. Breaking that one down just a little bit. Functional programming is a key concept. You probably want to describe what that is. And basically how it differs from some other types of programming, and then tie that into how it's done inside of Spark. Thoroughly critique the operation of RDDs in the context of Apache Spark, and then thorough demonstration of applying filtering concepts. So that's like applying where clauses essentially, but it's not exactly aware. And so with that, we've reached the end of the material that I've prepared for today. That is pretty much what you need to know about this module. As always, if you have any questions, feel free to reach out to me. That's what I'm here for. Stay safe, and we'll speak again next week.